So hi everyone, welcome to day 13. I think we're going live. Okay, we're already live. See the audio working. So hi everyone, welcome to day 13. And this series is about building a production RAG system, or an agentic RAG system, you can call it that way, that can process 85,000 plus documents and of course like 100,000 plus documents. And also yeah, I mean that's simply a RAG system that can that's sort of like a search agent that can look in through thousands of documents. And especially I want to show you quickly the amount of documents we're working with. I'll just quickly show you the doc. So I want to quickly give an intro about the project, and then we'll move on. I think that's better. So I'm gonna pull up my Notion so I don't confuse anyone here. So this is the fictional project that we are working on. It's called Meridian Aerospace. It's, yeah, again, fictional company, which is an aerospace engineering consultancy company that have about 180 employee, and they have a lot of aerospace documents, like documents from NASA, documents from SpaceX, documents from their internal documents, their research documents, technical reports, and etc. And those document would most of the time it's proportional test reports, safety analysis documents, failure investigation reports, and the documents are from 1990s. And this is the you can look it as this is an RFP, like something that's given from the client for us to us. And yeah, so this is the use case. Engineer currently spend 4 to 6 hours per project searching through archives to find relevant historical test data, failure modes, and compliance precedents. Critical institution knowledge is locked in the heads of senior engineers approaching a retirement. Last quarter, they missed a relevant failure mode during a safety review because the historical data was buried in 1997 documents. So this is one use case of them. They are having a lot of problem. Usually in a rocket, if you were to work with a company in the aerospace, aerospace industry, the documents they deal with are quite old. I mean, they're complex in the first place, and they're also very old. They're from the 90s, and the few documents that we are already working with actually from the 1951. So it's nearly 75 years of storage of timeline of a document. So the documents are very different. They scan copies. Some of them are handwritten notes. Some of them do not have metadata. They have very complex diagrams and etc. So that's what we are solving, and we've actually solved those. So let's quickly check in what the features that we've already done and what we're going to do today and the goal of the next few days. So just to give you a quick gist, we are building this for about 2 weeks right now. In probably 2 days, I want to complete everything and then share all the repo, the code, and etc. But yeah, the documents are 40% scan copies, so we have a lot of OCR, VLMs being used, and etc. Heavy use of technical jargons. They have a lot of jargons, domain terminologies. For example, LOX would mean something, MMN would mean something, NTO would mean something for me, and for someone in the aerospace domain is completely different. And more than the difference of like synonyms and acronyms, the domain terminologies would actually differ as the document changes. For example, a word that is, let's assume you're searching for chamber combustion. Chamber combustion would actually be written as stability combustion in a paper that is from 1990s to 1960s. So you'll have a lot of difference in keywords, in words, and etc. So if you want to find it, if you want to have a system that can accurately search for information, then you should be able to understand the domain terminologies a lot better as well. So that's what we're also solving. That's what we solved yesterday, and we're continuing that today. I'll go through them. We are working with 18,414 embedded domain terminologies. Usually I used to fine tune the model with all of the terminologies, but in this case we actually are using Claude. So because of that, we are building a hybrid search, that this keyword and also semantic search under 240 milliseconds, so it's like split instant, and goes into the agent. I'll get into what we're doing right now in a bit. So that's that. We're currently working on it. Mathematical equations, that's solved. We have formulas. Our document processor can process formulas, tables, technical diagrams, images, and etc. So that's done. Tables done. Cross-reference document, it's an agentic sort of thing. That's what we are going to do. So the project value is about $70,000, but in a real world scenario, the project value minimum would be $250,000. So the entire project that I'm building right now, and I'm not taking any shortcuts here. Last 5 days we were having issues processing 10,000 documents. I'll show that to you with only one H100, one GPU, and we're 50% done with that. Around 5,000 documents are already done. We have another, and we have about 500,000 tokens, something 500,000 odd tokens already in Qdrant. So we solved that, and the infra, building an infra with one H100 is really such a pain, and we've basically figured that out. I have no experience on infra. I'm just just using Claude to understand certain things, understand, go into deep levels, check each and every small part, and split that up in the compute with its GPU, CPU, and etc. So last 4 videos are on that. What you can do is that you can send it to Gemini, or I think it's called yeah, it's called Notebook LM. Notebook, oh, yeah, yeah, I didn't use it for a while. I think it's called Notebook LM. You can basically pass in all of the videos. These are 7-hour, 8-hour videos. Pass in, get a summary, and then start asking questions. How did what are the challenges we faced, and how did we solve it, and etc. Because those, I don't expect you to watch the entire 8 hours video for 4 or 5 times. It doesn't make sense. So yeah, that's the stage we are in. So I want to quickly show you before I move on the current stage, the current progress we are in processing documents. So you can see over here, we have about 17% of failure rate. Failure rates are normal. For example, like in 10,000 docs, I guess already we have 1,800 already failed. I hope we'll end up with 7,000 or something like that, and we have like 3,000 failed. But we can try another. We can try. This percentage of failure is too much. We'll definitely try it in a bit once the entire processing is done. But yeah, you can see the progress here. We have 10,400 documents, 5,552, 51% is already done. I think the failed 1,800 is actually wouldn't be a big of an issue, because we're actually processing it. We're retrying a lot of these documents. So I think we'll have more documents. We have about 3,000 to 3,029 in pending. So I think we'll have about 7,000 documents, and we will also do a retry as well. But you get the point. This is for 10,000 docs. This is just the infra for processing it. We've already done 36 hours and 20 minutes and 30 seconds. So it's running for more than a day, like a day and a half. And you can see we're doing about 110 pages a minute. We started with 200 pages a minute, and then of course with a lot of GPU congestion and RAM overloads, a lot of this stuff to retrying and etc. And with the pages being much more dense with formulas, more queries on VLM and etc., you can still expect it to. I was expecting it to perform with 150 at least, so it's 110. It's okay. We've already done by 50%, and yeah. That's just the update. So this is still going on. I can look up to Qdrant, but Qdrant would probably have about 500,000 chunks or something like that. And I hope this would be completed in the next 36 hours. So it's going to be 29th and 30th by your US morning by Friday. This should be done. That's the hope. And at least we should have a 7,000 documents with a 30% failure rate. Failure at a normal, but 30% is a huge number. Because a lot of these documents I actually pulled all of these documents from NASA's NTRS. So you can do it as well. You have a query limit of 500 per 5 minutes or minute or something like that. I worked it out. I just put it on the night, downloaded everything by day. So it took about 7 to 8 hours to go through entire 10,000 documents of PDF. And the PDF looks something like this. Where is it? Oops. Stuff like something like this. So very, very long PDFs. The average PDF, just see the average PDF itself. The average pages in a PDF is actually 67 when I compare it to the entire 10,000 documents. So you could easily see there is no way a document is going below 50 pages. It's not like a page or two documents. It's very long documents. They have a lot of tables, scan copies. They have images. Can you see like this image and etc. The formulas here, we have custom pipelines to accurately extract everything. Like we're not dependent on any parsing done by the framework. We're using Docklink, by the way. And yeah, that's what I'm saying. Yeah, accurately we were able to pass this. There's a lot of jargons we extracted as well, like symbols, nomenclature, and a lot of other removing noise as well. Can you see this confidential statement? We removed all of this noise. So then the pipelines can focus on things that actually matter, like this. So we did a lot of stuff. I'll leave definitely a post. First of all, I forgot what we did in the first place because we did a lot of things. I'll look into the code, use Claude code, and sort of try to get a full info on what are the challenges we faced and how I solved it. Because more than because you guys have to know the information on whether how you solve. It's not it's not a straightforward approach, and you will definitely hit roadblocks and challenges. So you need to be able to just take a different path of thinking, like a different sort of thinking, and then try to solve this sort of challenges. And we did a lot of stuff on painting images and then painting tables and doing heat maps, seeing the pixel density of white and black and putting a line automatically using PyTorch and all. We did a lot of those stuff. Not PyTorch, I guess Python or something like that, some package. But yeah, you get the point. We did a lot of graphs, did a lot of variations in graphs and etc. Boundaries. I leave a lot of them. So this is a quick like a gist or whatever. First 10 minutes I want to spend just to show you what's going on, what is the progress made. And it's also a reminder for me because I tend to forget a lot of things and forget a lot of things quick, forget a lot of things as I progress. So we're already there by 7 we've already, it is day 13 I guess, 13 or 12, I'm not sure, but yeah, already 2 weeks. So I just want to keep track of the progress we've made so far, and then we are on track to this Friday. Alright guys, so let's quickly go ahead and see our agent in action. Let's go ahead and start the web. And for the document processing, we're using a 8 billion parameters Quent new 8B version. I've loaded it up on FP8, so floating point 8 for Hopper, because we're using H100. But depending on your GPU, you can go with whatever setting you want. I would recommend you go with quantization 8, at least quant 8, or maybe if you're low in GPU, go with quant 4 using Olama. I did it from VLM because I do have VLLM basically gives you raw access to the GPU. Like you can do a lot of batching stuff. You want to write some custom. You want to work in tensor level. It helps you work on something. Work on at least on that stage at that level. So yeah, it's not worrying, no. Yeah. So I totally forgot. Cool. Yeah. I just wanted to mention the settings as well, because you might think, which with one H100, how am I really using a VLM in the first place and processing 10,000 docs? It's only because I'm doing it on FP8. So there's a small accuracy bump in terms of, the architecture behind the Hopper. And also you will also, it's not the full precision mode, right? So you'll only have very less. I think for the 8 billion parameter, just the model, I can show it to you. I can show you the terminal actually. Let me quickly connect to my this thing. Yeah, I'll do. And here I can expand this a bit, and you can see my GPU usage almost 100%. We're at 87 using 95. I've kept a buffer, and most of the time it goes above the buffer. This is the model, and it's consuming about 70 GB of VRAM, and it's a 7 billion parameter model again. So because that has 7 billion parameter model itself is only 10 GB. It should only take 10 GB, but this is for the KB cache. So in the entire batching, and we are processing 256 in a given go, like in one single forward pass. So I think 256 is on one parallel, no, one shot. So one batch. So let's say you have to have 256 requests. You don't need to concurrently do all of you don't need to sequentially do a lot. You can basically batch it, and batching also just in the sense of one forward pass. So you collect all the 256 and then do it in one single go. That's the most efficient way of doing it. This is what a lot of the companies behind Claude, OpenAI, and a lot of the consumer companies do, because they have a lot of the things they can serve consumers very much with a very limited amount of compute. It's only because most of the consumers, or like general consumers, they are not going to use 100k tokens, right? They were usually going to use maximum 10,000, 20,000, 30,000. That's what they deal with, like basic chatbot queries. So then what they can do is they collect all of your queries and batch it. So whenever you go to GPT and type in something, right, your process is actually not a single sequential process. It's actually batched. Your request is actually running with another, I don't know, a million users, like million API, million batches done, and then the entire batch, whatever the whenever your request sort of completes, you'll get that back. But it's not like a sequential process. It's basically like a batch. So that's why you see sometimes when you type in ChatGPT or Claude, sometimes you get a quick reply, or sometimes it takes a while, a little bit. It's not because of the model loading and etc. Everything is fast. They're serving millions of users. It's just that they have a batch. Let's say 500 requests for this request, and yours was your request was probably in the 499. It's waiting. The batch is waiting until those two requests come in. So someone on Ethiopia, or someone from Russia, or someone, sorry, not Russia, someone from US, or someone, it doesn't matter. I mean, of course it matters because they have geolocations as well to serve your needs much faster, like in terms of compute, I think, at least. But overall, the whole point is that it'll definitely be batched. So you'll have like a like 20,000 requests being batched. Depending on the GPU, if it can handle 20,000 requests in a single batch, you can still do it. And then your request is, that's one of the reasons why you see a small drop in performance, because it's waiting until all of the other requests come in to go to a new batch. So that's how, with limited amount of GPU, these guys achieve or serve millions of users, like millions of concurrent users and etc. It's mere compute. It's just infra, nothing on model level, to be honest. And yeah, if you were to go through all the videos, you'll get a good chance. If you're building like a consumer app, you only have very limited amount of compute, and you want to scale it to a lot of users. Watch my videos. You can literally scale it 10x to 20x, and also plus the speeds and etc. So yeah, cool. Just wanted to just give you a sort of sense, and also get myself some sort of sense, because sometimes I would probably miss a lot of things. For example, if I don't look at this GPU consumption, some of this Python. So so you see this, right, or this 8 Python servers, these are docklink servers using layout detection. So that's why we only able to process 8. I could have done in a thread, but Dockling uses a PDF issue, and it couldn't support. It has a lot of issues with threads and etc. And it locks the thread to a particular process, and just a nightmare. I regret using Dockling in the first place. I could have used some other layer detection, and yeah. But either ways, we've done it, so we've sort of had a workaround. If not, we probably would have been done by 7-8 hours or something like that. But I hope, like most of the companies you're working with, I'm sure half of them would be startups, half of them would be well funded companies with a lot of compute. So you can just get a B200, couple of B200 if you have the money, and just instead of paying like $3 or something like that an hour for two H100s, you just get one B200 and then just do it in two days. It's only $5. So the math will round up either ways if you have good access to good compute. And you would probably need to, and always use the best GPUs available. Use keep a buffer of 10% or something like that for unexpected surprises, and then have watchdogs that could monitor. Even we have watchdogs here as well, so all of these 8 servers are monitored by a watchdog. So in case something fails, the other request will go to this server, or this PPPID, this server, and the other one will be booted up in less than 3 seconds. So we have watchdogs as well. So yeah, cool. I wanted to let you know on that, because sometimes when you watch this video initially, you'll be like, what the hell is this idiot doing? I don't even understand. What we're building a basic chatbot. That's it, chatbot with tools. That's not the case, right? That's what I wanted to quickly give you guys an intro on the past videos, past progress, and etc. And we'll move on right now. Terminate. All right, so I'm going to start the server. Now, this is first of all, I'll show you the fire up a query and then show you the chatbot. End of the day, it is a chatbot. So I'll show you the bot right now, and then okay, so with hi. Okay, nice. So yeah, just a gimmicky UI. So like I'm very bad at UI and etc. But this UI looks very good. It's only because I used Claude's info. Yeah, basically it's Claude skill on front end skills, and it sort of gave me pretty good UI. This is like very decent compared to other UIs I built. Like the initial UI itself and plus the components, the buttons, etc. is very much standardized. Looks very neat for like a like the domain that we are working with. The fonts sort of talk very different. They mean a lot. So this looks good. I'm gonna quickly show you the and if you want to look at how we did the agent in the first place, I guess it was day 4 or 5, 4 and 5, I think. Day it was part one, part 4 or 5, day 4 or 5. Check that. We went through a lot of things like theory behind, understanding users' perspectives, the users, and generally it's not about coding, right? Coding is it's now easy. You can code with Claude Code. It's nothing. But what do you code? Like you need to have some meaning of code. You need to build something solid. If you want to build something solid, you need to have a super crucial idea on the users they're using the platform and etc. So we did a lot of like simulations, user simulations and etc. before even we touched the agent, before even we touched how a system. Basically we brainstormed and looked at how a system should actually work for a particular user. So definitely worth checking out if you just want to check on the agent part, not the document processing and all the infrastructure. If you don't want to, if you want to avoid all those noise, 4.5, go ahead and check it. And I want to put this request. I'm trying to validate a performance code against the methodology in this report. I need to verify the exact equations they need for their combustion parameters. First, find the formula to calculate the afterburn equalization ratio. It should be simple fuel to air ratio. I expected it. Yeah. So basically, I'm just trying to find some formulas. Okay, I'm just gonna fire this off. It's asking like because that's the only thing in Qdrant right now. This for testing, and you can see you can search. It can get adjacent chunks, meaning like up and down chunks. View image, can view verify. Like for example, formula might be corrupted in some sense sometimes. So it could actually take an image of the PDF and verify that as well. It can update. It has its own notes as well. It can also have it has its own tasks as well. So you can see sources. Hey, if I click on it, you can see the entire sources, and then you also have C sources here. And if I scroll up, you can see all the and it all basic stuff, basic agentic stuff, just a bunch of tool call, and you have the responses. Cool. Now what I'm working on right now is save actually. Open up Qdrant and show it to you guys. So here you see NASA Thesaurus v2. Right? NASA Thesaurus is a publicly available standardized sort of, maybe you can assume it to be like an Oxford dictionary, or like a dictionary with all of the domain terminologies from NASA, that in not just NASA but then generally in the space, in the aerospace industry, earth sciences industry, astrophysics industry, and all of those scientific sort of research industry, and that's related to space and etc, aerospace and just space and um, space research and etc. They have very much standard. They have a lot of standardized domain terminology, and they have a lot. For example, if I have to scroll down, you can see this concept ID 37805 actually means a European Airbus A300 aircraft international corporation. Wait, this is a very bad example. So as I did mention, not just aerospace docs, but also anything related to space research, aeronautics and etc. And aborted missions would actually mean aborted apparatus, abort trajectories, destruction, engine failure, escape rockets, escape capsules, and etc. So when the agent moves, or maybe when the agent actually, let's say you fire up a query, let's take this example over here. I'll finish it in 2 minutes. Before I jump into code. So, what thrust chamber failures have we seen in bipropellant systems operating over 2000 psi? Now, this 2000 psi would actually have a different meaning as well. Yesterday, we were checking on to the Claude, we were checking on Claude and etc. And we came with a number of 360-n or something like that. There was a good number, I think I can show it to you. And Yeah, see this query processing 2000 APIs. So you can't directly search for 2000 APIs because over 25 years, all of the unit, you'll have a lot of unit inconsistency, and this is one. Like you might use PSI, you might use MPA, you might use KPA or ATM or whatever, NKN, inches, MMCMs, whatever the dimension, stuff would have changed. So you need to be able to, like, you need to be able to search. If you don't find information, you need to have that right domain level knowledge to be able to search properly, because you're not searching ABC, you're not searching for bananas here, or you're not searching for apples and bananas or mangoes like that. These are quite different, and a much more better example would be, if I were to scroll up, you can see LOX would actually mean liquid hydrogen, I think liquid nitrogen. Let's see. Yeah, bipropellant oxidizers would actually mean, and specific bipropellant oxidizers MMH, NTO, N204, MON1, MON2, and etc. LOX, yeah, and all of this stuff. So some of the words that doesn't like, I don't even know the meaning of certain words, but yeah, I can understand. But I do know that there's a lot of domain terminologies, and the model could also be a generalized person like me in case, but it still needs to search up keywords at this level. For example, if you were to say biopropellant, I think you might need to pull up LOX or LDX, I think, or it's liquid nitrogen, I'm not sure. But yeah, you get the point. It's all about getting the right terminologies and searching them in the documents. Even though the user were to mention liquid something, the model should actually search for liquid something plus LOX. Then only you'll end up in the right, you'll end up in the right documents. If not, you'll never find liquid nitrogen could be mentioned in some sort of basic paper, and LOX would be different. The embedding models have no clue LOX has connection towards liquid nitrogen. Maybe it'll have a little bit of clue in terms of like connection points, but only for big models. We're using a 4 billion parameter model, that too in a 4 cont option. So then we can't expect a lot from a embedding model like this. The prediction could be very much worse. So because of that, we need to put a lot of work in this. So what I've done here is that so domain terminology is done. We already have it in Qdrant. You can see 18,306 or something like that. We have two options. Let's say I want to type in the same query, right? I typed in something before. I'm trying to validate the blah 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 blah. And what I can do is that I can run a small model to actually extract the key patterns and then perform a search, hybrid search. I'll get into how we do the search. Quick search in Qdrant, get the terminologies, and then give back to the model. Now if I were to go ahead and run this, go ahead and run this as a second message, it's very inefficient to run the Qdrant. Of course, even it's in milliseconds, it wouldn't make sense to run it on this particular text because it's conversation. Just because a user just because you have a user message, you can't assume that it will have a lot of key jargons. Now the second thing is that, let's say the user was to type in a message and the message is on the way. If I were to type in this particular message, let's say we extract the keywords and inject the specific domain terminologies, but this is only dependent for this particular message, right? Like there could be much more. Like this is one action. Just assume one action, and the agent takes 10 to 20 actions. If you were to do it in this approach, in terms of action, you'll only inject for one action, and afterwards the agent will only have to work with that specific text, just that specific text, which is very inefficient. Like the agent might search a lot, like it might come across a lot of information, you might come across a ton of information, and it could actually search a ton, and it can actually that's how the agent would work, right? That it's not going to work in a single structured way. It will search a lot of things. So whenever it comes across new information, we just need to expose it to new terminologies. So this seemed very inefficient for me. If it was fine tuning, then it's a different story. This seemed very inefficient for me. So that's why I added this as a tool call. So the agent basically is sending this
Stoichiometric.
What?
Stoichiometric. Stoichiometric. Stoichiometric.
Okay, stoichiometric. I'm sorry. These words are quite new to me. So stoichiometric, I think. And then yeah, you can hear it from Google. Thanks for me.
Stoichiometric.
Yeah, this ratio, and of course, you have air fuel ratio, combustion parameters, and etc. And you can see over here, for each results, we're giving them the synonyms and also related names for it. Of course, it's not a very good it's not a it's not a proper test case here. I'll show it to you when we have, for example, see this oxygen consumption. It brings up some irrelevant stuff as well, respiration, oximetry, because we don't have, not so note that we don't just have space stuff, we also have like very different domain stuff with earth sciences, biological stuff, and that could come in. There's a lot of noise here as well. But that's the overall point. The agent would need to have access to a search like this, so then it can actually pull in the right keywords, like the right domain terminologies, and then use that to work towards it. And at this particular case, I don't think it's quite helpful, but it's, as a tool, is quite helpful, depending, because we can't predict, we can't assume that this is the use case the user might use it. We just have to make it sure it's more generalized and could work for any scenario. And if there were noise, it should be intelligent enough to filter the noise and just use the information that's available. So that's the whole point. But you can see over here, for combustion parameters, we only have one. For afterburner relevance ratio, sorry, you have only one. But what I want is that whenever you work on something like this, you'll have a bunch of other keywords. Like, you'll have a lot of keywords. Like this, the third one would make, or let's say we only fetch for 5. The third one on line would actually make more relevancy than the first one. Not relevancy, would make more sense than the first one. So what I have to do is that, and overall, you get the point. Right now we have all of this stuff. Right now, domain terminologies, we'll wrap up domain terminologies, and we'll start on a new Claude conversation to see how we can make this efficient for 10K docs. Okay. Oh, sorry. Stoichiometric. And also, I think the prompt itself is bad, so I would say, so let's fix that now. Oh, hey guys, I just saw your messages. Sorry about that. I'll quickly go through them. Sorry, I didn't have the chat open. So, hey man, just came across your live and account. Are the recordings saved? Yeah, man, it's actually saved. I'll uh, I'll send the live now. So check this, go to live, and everything is saved. We're building this for about 4 days right now. So FX Tatya Vinchu, I think if I spell your name right, here's the link. Go ahead and watch the previous recordings. Paul Singh, hi, I've been following your live stream for this project. Very helpful to get on an on-depth look on someone's approach to kind of this project. Exactly, that's what I wanted to do. Thanks for tuning in. The overall goal is to just really show you, what what does it take to build a project like this. And it takes a lot of work, a lot of thinking, and a team to build something like this. But with Claude Code, God's grace, I think we're able to build this in a few weeks time, but usually these projects should take 3 months with a 5 to 6 member team. And of course, even with Cloud Code, it will take a lot of time, but this is something, we are avoiding a lot of the noise and doing a lot of simulations and having conversations with Claude, and then building it through. But in a real world scenario, you will have a lot of calls, and I encourage you to have a lot of call, get as much as information as possible before you jump into code, and understand the domain as much as possible. So that's exactly what we're trying to do. Overall, this is what we are trying to do. I wanted to so yeah, this is sort of it. I think I'll have the GitHub repo in some time. Maybe you guys can check it out then. Apart from that, I think we're good enough. What else? I plan to at look at someone's approach. I'll have, I think, some posts or Medium articles or something. Like, so you get a good quick gist. Okay, this is the problem, this is how you solve it, and you collapse. You can just go ahead and then make the changes. So watching like the 7 hour recording, because I've spent half the time debugging stuff, like, and you can see the errors that I faced just live and how I solve with the thinking patterns and etc. Hopefully that will help some of you guys. And your second question, is there any way you might share your repo to make it easy to follow? I might share the repo. I'm not sure if I'm just working on it. I would at least share the repo on document processing pipelines, and I want it to be open source as well. So yeah, give me a follow on Twitter. And I'm not active on Twitter. I want to post something. I think I have to find the time for it. So yeah, just go ahead and give me a follow on Twitter. And if I were to post any live repos, you will get it from there. Okay. Awesome. Thank you guys. I'm just gonna thank you for your questions. I'll just monitor the comments going forward, and yeah, we'll just continue. And currently, for each item, the equal which, yeah, man, sure. Currently, for each term, the agent looks up. We fetch 3 top notches for Thesaurus and aggregate this thing. Wait, I don't understand, but you have to. Yeah, so this is how I wanted to have, because we need to have access to this concept keyword as well. Because before it was actually merging all of this to one single keyword, which is very wrong. Right now, this is what I think will be used. So I'll be like, just to validate this. Um, Now I'm just testing the domain terminologies tool. So just call the domain terminologies tool and give me an output. And if I confirm, proceed to the next stuff. And please don't ask me any questions. Okay, you can see a small, it was a bit slow. I don't know why, just a second slow. I saw that. Okay, okay, this is good. Is this useful for you? I'm just trying to understand, is it really useful for the agent? Because agent is going to perform it, right? So I'm just trying to get its perspective, because that's the natural way of, because you don't want to force the agent to use this always. I want you to use this, or I use a search query and etc. That's not the case. You just try to say, be in the shoes, and if you think, if it this would actually help you in this way, and use it for this particular scenario. And then if you were to remove all of those examples, and like few short examples, and just generalize the pattern, that should help out. And that's how, we from day one we only focused on generalized domain intuitive, yeah, that was the goal of building that sample agent. So that's one of the reasons we researched through a lot of simulations. I'll quickly show you the simulation. So when I say simulations, it's not about, like, I'm not doing like, like doing stuff like in the matrix or something like that. It's quite simple actually. You have your understanding of what you're building, and then what you do is that you create personalities. Okay, for example, it's, you have an aerospace company, and you're working with aerospace companies, have junior employees, senior employees, and etc. So you want to understand how junior employees would work. And then what you do is that instead of asking how would a junior employee work, I want to understand the day to day. If you, without asking that, you create personalities to those, let Claude generate personalities. That's just a personality with 25 years of experience. They've been 90% there for all of the research stuff they've created, been there for the failures, been there for the success, been there for whatever the stuff is there. And then you have that personality, and then you create simulations for each personality. So you can see here phase one, understanding and planning. And let's say, I suppose simulation in the sense that, if Sandra were to, you first of all you have to get all the personality right, and then you will be like, if Sandra were to use this platform, how um if Sandra were to use this platform, how would she use it, what are the steps she would take, and etc. And we come up with a very small query, and we would see how the agent would need to sort of work on. So you can see agent will do this. It will have a notes pad, it'll have this, will search this stuff, this is the agent's reasoning, it'll update the task, and this is the agent's actions, this is the key findings, this is the action, and etc. So you do simulations for each query. So the overall goal is to understand how the agent's nature should be. It's not a general search system. There's so many functionalities, there's so many function not functionalities, so many intricate parts. So you want to get those right by seeing the simulations. Usually in a real world scenario, what I used to do is I go to the company and I see how the employees actually use the platform in the first place. Like, how are you guys really using, what is your traditional search system? I sit near them and just see how they traditionally search, what is their roadblock. And even if I can't sit with them, you can't usually sit with them, these guys are very busy for sure. They're not gonna pamper you or spoon feed you with a lot of stuff, but have a ton of conversations. Randomly ask questions, randomly try to understand. Don't go with the bullet points of things you want to know. Of course, go with them, but also try to be ask random questions. And of course, with GPT and Claude, you can do a lot of simulations. You can understand their work and etc. So have a lot of calls, have a lot of information, dump it in your brain, so dump it into Claude, and then get key points and whatever before you jump in the first code. So this is what one simulation. I had about 3 simulations done for very different scenarios with Claude's understanding and etc. So this just helped me to craft the initial system prompt, because system prompts plays a crucial role a lot of people, I don't know why, they want to build, they want to do, they want to, like, whenever they see, you want to make the agent great, the first thing they do is to go ahead and, add the tools and, making, do all of these stupid complex things like adding semantic layer, adding graphs, adding this, adding that. Dude, get into system prompt and get your system prompt right. I want to show you my prompt, right? Like, this system prompt basically influences the influences the model to think like an actual aerospace engineer, because you don't need to go ahead and prompt every single thing. For this scenario do this, for this scenario do this. You don't need to. The model already knows how, person X in aerospace company would actually work, and how the documents are usually structured, and etc. And you can see the system. You're an expert research agent embedded within Meridian Aerospace, a consultant in this thing, blah, 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 blah. You're not a search engine. You're a reasoning agent that uses search as one of your tools. When your user presents a question or situation, you engage your full domain knowledge and engineering intuition before, during the investigation. You understand the physics, the failure modes, the regulatory context, operation realities, and unspoken concerns. Your knowledge of aerospace engineering, propulsion systems, fluid dynamics, related domains are part of who you are. Use it. When a user describes a symptom, you should already be forming hypotheses based on understanding of what typically causes such symptoms. When they measure pressure value, you should have the intuitions of whether that's a nominal or concerning. When they reference a component, you should understand how it functions and what it fails and what its failure modes are. So if you were to, dump in system from dump in examples for each scenario, you'll be dead. Like, you can't get it right, and you don't want to spoil the agent with a lot of noise. So what you try to do is that you understand, you create simulations, and you try to see what does it take to, for the agent to do it. Is it I mean, of course, like, I mean, there's a lot of moving components, but one of the most important component here is getting the system point right. So usually a lot of people spend a lot of time, I don't know, adding tools, going to semantic layer, using graphs, and just because engineers like to work on very complex stuff, no? And of course, people who are quite smart, they also want to work on a lot of, complex stuff and figure this out, this and that. But usually it's so simple. You get your system prompt right, you have the good flow in tools, you have the good document processing. Of course, everything is like a pillar for a system like this, but getting a system prompt right will actually make wonders, to be honest, because it just gets it, like. And it needs, I mean, of course, it needs to be in a flow, and I want a single person to design it. I usually design it myself, so I understand the entire perspective. Because if you were to give in a team, not sure what sort of stupid actions will they'll do, they'll have their brains, they'll, come up with their intuition, their way of doing it, and etc. Of course, you have to do it together, but try to, be in a try to be in a flow. That's what I say, flow. I'm not able to explain what a flow would mean, but try to be in a flow, get into a good flow, and then try to craft your system in the most what do you call most efficient way possible, starting with the processing, and then, swiping as we can. Because the thing is like this: when you mention stuff like this, right, you present a question, you engage in full domain knowledge, and because you're basically, like, the models are already trained on engineering documents. Like, you don't need to go ahead and tell these documents are like this documents are like this document is like this document is like this. You don't need to, like, you don't need to go ahead and sell everything to the model. What you can say is that, this is this sort of domain, so you would know, use your domain intuition on how the documents are structured and how, what's the nature of the documents. And if you were to say that, then those trained information will get, actually, just looking, even if you look at like neurons in a brain level, we don't know what's happening in between. But when you put this information, I'm pretty sure all the training data, or the personality shifts, or the personality data, or whatever, when you put, like, when you use words like this, it'll actually spike up the domain intuitions, and it'll actually have that loaded in the model. Okay, then it'll be like, okay, 1970s documents are usually like this, they'll have a lot of issues in formulas, we have to go ahead and take an image. Understood? Stuff like that. So, get this right, and you'll pull off most of the hard parts. So get me a better strategy finding exact equations, steer code metric constants you need really proceed. Okay, so I think I want to try this one more. No, so you can see over here, for one this thing we have like very different matches, mass ratios, we have stuff like this, and I want to see if it actually is going to use this. So I'll I'll just send this. I'm like, don't ask me any questions, just get started. And it's searching, it's not using any domain terminologies here because I've not hard coded it to use it, like use it before in any search, but I want to, because I'm not doing any ingestion right now. I want it to have, use, I want it to literally look into that. So I'll be like, show me the system prompt or the tool prompt and etc. for, actually, I'll see that. And you can see over here on domain terminology, you have access to NASA's Thesaurus, a comprehensive collection of 18,000 aerospace domain concepts, synonyms. The Lookup terminology tool can help you expand your search. Actually, the thing is like this. I don't want to expand your search. Before searching, look up technical terms, but still it did miss it. I didn't search for it. If you encounter an unfamiliar economy and terminology, look it up. The thing is like it needs to use it always. Discover related, confide related terms that might lead to. I'd be like, so the model didn't use it, right? So I just want to know, the be honest here. It's totally okay, but let me know why didn't you use the lookup the domain terminology tool? So I just want to understand why didn't you? Maybe it didn't like there was no reason to use it. This is probably a very simple query. That's why I didn't use it. Oops. I made a judgment call. It wasn't necessary, and I should be explained why. When I read a question, you were already using precise domain terminology afterburner equivalency ratio. Oh, okay, that's the thing. My semantic hit perfectly with NASA's come back immediately. Okay. So can you give me can I'll be like verify equation, yeah. Can I use it upfront? So what I'll do is that trying to validate this thing first, find the formula used calculate the. Okay, the thing is like this. I'm testing the, can do it here itself. The above is the query I am using to test Claude, I mean my agent, but I guess we all, the thing is like that the agent doesn't even use the lookup domain terminologies tool because I think or it did confirm that it didn't have the need for it because why it didn't have the need for it because we already gave like very clear information or very clear jargons, right? So what I want to do is that give me an updated query, of course the same task, but then just remove a lot of the domain terminologies and just be vague, and hopefully the model should be able to figure out the right the goal is that model should be able to figure out the right acronyms or synonyms for it or terminologies for it. So I'll get back a query that is quite vague. I'm trying to validate the performance code against report and to verify equations that used to fallibility ratio. This means okay. So what changed? How much extra fuel is being burned in the reheat section? Nice. Now the thing is like this. You can't go ahead and search this, right? Like how much extra fuel is being burned in reheat section. You can't search this in NASA's the domain terminology. You don't have this. This has to come from training data, and that's why fine tuning becomes more important, much more accurate in this sense, because you can capture those nuances. Still, just go ahead and give it a try. And you can see the updates. It's updating its task. It's running parallel search. I don't know why. No, I don't want this. Will be like, please use the domain terminologies too. What did it search for? You can see afterburner, reheat. Let's say what did we get for reheat? Heat gain, entropy, whatever. Let's see the parallel search queries. Burning efficiency. Yeah, I think afterburner ratio. Could you see this? And let's search if we got that right. So the you can see this is truncated. The in the agents tool call, I see this to be truncated, but I want to see everything. Please don't truncate it. But I can see afterburner equivalence ratio where maybe it came in through because we didn't mention anything on afterburner equivalence ratio at all. But maybe it pulled in from maybe it was part of the terminology lookup, or it was probably from the models training. Either way, as long as you end up in the right spot, that's enough. Okay, this is part of the training, I think. It came in from the training, and I don't think this is helping much. Generally, it's not really helping a lot in the sense of it'll actually help because model we're using a good model right now, Claude, right? So it has good understanding of like when to avoid noise and when to use it. By default, it should have that. So I'm not gonna reprompt it and hard code this, but I can see I'll be like here. Be honest here. Did the domain terminologies really change the way you perform the search, or was it merely not useful? Be honest, no problem at all. I'm just gonna directly ask it because I mean, Claude is only using it. I think no is the answer, at least for this particular use case. Right to call honest answer, it wasn't useful in this case. I already knew relationship, afterburner, reheat, synonyms, inject in content. Terminal Jacob giving me relationships I had already understood. When I constructed my product, I was already using the right language. Yeah. So why I'm doing this is that if you were to work with open source model that is not quite aware about terminologies, you can still in a good spot. You'll probably end up. Uh, yeah. Sorry. You'll end up in a good spot for a model that is quite not quite unfamiliar with the acronym and etc. Actually, this is quite simple query, but I want to try a query that like has LOX, should be able to pull LOX or something like that. Like maybe for this, maybe what I'll do is that I'll just try we talk to Claude and please use the lookup tool, domain terminologies, and don't ask me any questions. Was the domain terminologies tool helpful for you? Did it give you any new info? Or like would have like could have this influenced your search in any in a positive way? Most things I already know. Okay. Yeah, cool. The thing is like this, because it's Claude, right? It knows every damn thing. It's pretty good, I think. So because of that, leaving it as it is. But yeah, you can see if you were to go with an open source model, definitely like info on like this would actually be helpful, right? Overall, I think we're in a good spot. We have domain terminologies done. We have about 18,366 domain terminologies I'm already done. And I also want to check my document process. How long have we done? So let's see. CD. All right. So anyway, I think I want to quickly show you the amount of documents we already have. So source V and V. Then try to activate it, and then see the search POC and this. Okay, so here is this. You can see we're already 56.8% done. We've already processed 5,000 documents. We're working with 10,000 odd documents, and this system can actually scale for more than 100,000 documents. That's the entire goal. We have one H100, and we're doing about 112 pages a minute, and we're doing a lot of document processing and etc. for the folks who are right now watching and etc. So yeah, I think we have another. We'll complete the entire thing in about, I don't know, in a few days, like today or tomorrow, like end of tomorrow or day after, and we should be fine. So if anyone is interested, go look at my past videos on GPU and getting this stuff parallelize it, like all the GPU stuff, LLM stuff, and etc. For 10,000 docs, and that's at Qdrant we have about 500,000 chunks. I think right now it should give us a good point for us, starting point for us to start the agent. The thing is, I'm not happy with domain terminologies. So what I will do is that um, I'm gonna quickly send this particular simulation of whatever the information we had here. For example, this looks very good. I just want Claude to understand why we're doing the domain terminologies, because I'm not happy with the way we have structured the prompt. So I'll be going to simulations. Hmm. Just save it like this. Because I'm not quite happy with happy with the system prompt. We have access to this and this, and it's just such a damn noise. I just don't want that. The thing is, the model doesn't use it, and we are not forcing it to use it because, like, if the model knows about it, then why use it? So let me through the document give you an assessment what the document imagines: expansions, a trust chamber, combustion, this bipropellant and manage and all failures, anomalies. This would generally be useful for us. What we actually got from your test synonyms, you get medical terms, schematic, no synonyms found. Afterburner equivalence ratio only matched afterburners combustion. The answer says true broad covers all aerospace, not propulsion specific, and missing critical terms that propulsion engines actually use. Document's own warning. The NASA Thesaurus help it compare the starting point, not a complete solution. Honest answer, the semantics has already handled this. Model embedding is models might also capture trust chamber, combustion chamber without explicitly. The agent's domain knowledge in the prompt already gives it guidance to think about synonyms. Yeah, if the agent's reasoning could be better. Yeah, I think I think we should do two things. One is 18,000 is a lot, and I think it's creating a lot of noise because you're having medical terms and all of this unwanted terms, which is of course creating a lot of noise. If we were to fine tune the model, then fine. But if we were at this particular scenario, we need to just get we need to filter it based on only propulsion sort of terms and like space related, like whatever the domain we are working on, something that's very much focused on that. So we need to be able to filter that and we need to process that. So we'll go through how we'll do that next. And also I think we're doing like exact keyword search and also hybrid. Maybe what we should do is that we should augment the search. So instead of actually searching just a term in embeddings, we'll actually expand it with whatever the knowledge Claude already has, and then search that based on that. We might end up in a better position. So those are the two things I want to work on. Let me know your thoughts. Yeah, because I think even though we have 18,000, I think it's a lot of noise. We have aircraft and really, and because it's the thing is like this, embedding models will be much accurate when you have a lot of text. If you were to do like simple text, like European Airbus, and then you have another Airbus, it'll have a lot of match, right? Like the embedding models is not trained much for very singular information, not for very small information, not for text. That's why you have keyword matching for basic text or fuzzy matching or whatever the matching you want, similarity or whatever. But for embeddings, you're trying to relate it to like a meaning of maybe a paragraph or something that's quite what do you call it, quite detailed. So then what we need to do is that we need to reduce to one thing I can think of is that you just reduce it to very specific propulsion related parent terms, and then you also make sure that the query is also augmented. So you filter the propulsion, the problem 18,000 general also creates medical oxygen aviation. Yeah, because it's still noise, right? The embedding model is going to suffer from this. And method hierarchical filter also terraces both and narrow relationships. Only keep the propulsion related parents. Medium key method keywords filter. Keep terms containing propulsion keywords in preferable. Manual curation have Claude. But actually, I'd suggest hierarchical. Yeah, with Claude's knowledge is expands it, and then we get better acronyms. I think because we can use that training knowledge here. Okay, please update this into the domain specific terminologies document, and let's work on all of the steps, starting with step 1. Yeah, I'm not sure how are we really going to filter it based on the right proportion, because I don't think there's any keywords or tags. Um, see. Okay, I should have saved the research. Uh, I don't think this will be useful. We'll just run it off. But I think what is actually useful is what is actually useful is what is actually useful. It's only we just have to load those right 2000 or 4000 words. That's it. That's what we want to do. No point analyzing this. I think I can be wrong. No, I think just so manually. Yeah, so can you see all of this keywords? It's only basing all of this based on this keywords. Now the thing is like this. Okay, so we have engine types, components, propellants, specific propellants. So okay, so it's basically we are trying to just filter out in the current 18,000, with acronyms with medical stuff and all of those noise, because we are not fine tuning the model and we cannot fine tune Claude. We wanted to reduce the noise in an embedding space because we are not working with paragraphs. So usually the embeddings would struggle to get something accurate here, and you wouldn't like for very small, like couple of text keyword is fuzzy matching would work, but for embeddings in semantic search you would just need to filter it as low as possible and then augment the search. But we'll give it a shot and see, this is worth trying. Has propulsion keyword, has propulsion concept, filter thesaurus, analyze filtered, save filtered. Yeah, so just filtering in the 18,000, trying to get something that's only as relevant for our, aerospace slash propulsion sort of documents, because usually it's NASA documents and we're not going to deal with a lot of medical stuff. That's a very odd use case. So yeah. Okay, this is a good number, 18,226. However, some expected terms of filtering, good. I think, yeah, we just need to change that up. So we'll end up with about 4,000, I think, and then we can chunk it. Anytime, I mean, if we want to switch back, it's still there. We still have both of the 18,000, the initial one, the version 2, and it'll be version 3, I think. Top level descendants. I think this time we found much more. We have 300 yeah, 3,581 focus terms. Most we verify the output and check for problematic terms overlay test. So I think we'll end up about 4,000 words or something like that. I think we should have better, yeah, a bit more. Done. Okay, now verify oxygen consumption. And also, guys, if you have any questions, feel free to drop in. I'm happy to share any info that I have or any, like, if you're confused on anything, feel free to question. Send me a question and I can give you more info. But yeah, right now we have 5,575 concept, 80% reduction, and we'll definitely see how it would, come out. So Ramandeep Singh. Okay. Hi man. Hi, I wonder how you would deal with rolling back changes to your DBS and how do you reflect updates, deletes in the data you have your graph? No, so I'm not using any graph here. It's purely semantic search. I'm not using graph rag here. So that's one thing. How do you roll back changes to your DBS? So for Quadrant, of course, I manage backup usually when I do for this use case. I don't have backup. I usually have backup. You usually have three backups, usually in very different regions. And if one were to go down, just pull in back from that, and you usually have a backup that you can pull that up. But in terms of updates, now initial basic updates like adding a document or adding a document or filtering document, that's totally okay. That's quite simple to be honest. But actually updating a document, updating, like, for example, usually in the companies that we work with, you have 10 documents and 5 of them will be draft and 7 of them will be drafts. And no wonder you'll just, you'll index it, you'll create metadata and everything, and you will save all those stuff in your Qdrant or whatever the DB you're working with, and then you have the actual production file coming in. That's the actual file. Now in a sense that we see, in a sense of relevancy, you would only actually need, you don't need to focus a lot on the drafts, but this new document would actually be the production one. That's one use case you see a lot. You see a lot of this in legal documents, or and not usually in legal documents. And if you were to work with legal documents in scale, definitely you have this issue. We use a lot of pattern matching, we use a lot of file name conventions, we use a lot of like pre-processing in terms of analyzing the first 3 pages, analyzing the last 3 pages, and all of those stuff, and then we try to put that up and try to create metadata for that. Yeah, sure, for sure, man. Anyhow, good luck. So I think ingest filter propulsion into Qdrant, create a new collection called Propulsion Thesaurus. So this will be the V3. We already have 2 versions. Now we'll create another one and we'll run it. And yeah. So I'm gonna run this. Okay, you should have it here in Propulsion Thesaurus. Nothing, but we'll have better. And second, we'll have but we'll like, it'll take a bit of time to process all of this, right? So we'll jump. We don't not want to waste time. We'll be like, and I'm running it already. Until it comes back, we'll actually work on step 2. Okay, Ram Sandeep Singh, I'm actually going through a similar problem. but your use case involves documents to be ingested, re-ingested again in case they update it. Yeah, that's the thing. Now I have a custom pipeline for it. Let's say now they very depends on very scenarios, right? Depends on very much the scenarios. But let's say a new document is actually coming in. You can have a quick filter to see what similar documents of, if, like for example, let's say, you know, it's a contract, right? Raj X, Raj X, Randeep Singh partnership or something like that. That's the contract, and you have various different drafts for it, and you have metadata initially processed to your, what do you call, to your Qdrant. You already have that unique data processed to your Qdrant. Now, when a new document comes in, instead of re-ingesting it directly, you can have a pipeline in between, or in the front, where it checks the first 3 pages or the last 3 pages and gives you a proper metadata. Using the metadata, you can try to find very much related documents. Now, of course, this is an agentic process. You need an agent, or you at least need a very small model to work on this. But then the model will identify whether this document is related to this specific document. And I'm pretty sure you're pretty sure you're only working with thousands of documents. I don't think you're going to that 10,000 range. If that's the case, you can utilize a very small model and do that, initial filtering or check using a model to see. You mean something like git diff? No, 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 no. I'm not talking about git diff at all. um what I'm trying to say is that no, you can't do git diff, right? Like for example, like I'm not sure what documents you're working with. Let's assume it's legal documents, right? You can't accurately predict the changes. Like for example, like a small change, just a number would change. Let's say you were by the production version might have uh, a contractual valuation of 10,400 instead of 10,000. That 400 is not a big difference, but still the production version or the most recent version is actually 10,400. Then what you have to do is that you want to do some sort of initial pipeline to be able to scan. If something like git diff, you can do it if you can, but I'm not sure how like use that understanding in a legal sense or whatever the domain sense. If it was like code files, you can do like a git diff, and that could be quite easy. But yeah, for legal docs, you have to first of all get that base amount of understanding with this doc, because I'm pretty sure the file name would change. You can use it with that, and you probably can depending on the document you're dealing with. In a legal doc, initially you will have the dates being changed as well. With that, you can find the difference. So depends on document by document. You'd wanna it will really depend. And the issue is that you don't have one single solution that would actually solve all of this. So yeah, you just have to do a ton of manual work here. But yeah, that's what I'm saying. For to be re-registered depends on, if for example for aerospace documents and etc. Exactly, yeah, we have yeah, exactly, that's what I'm saying. You just have to base it on document metadata, and also have like a very small model that can find, let's say one document comes in, right? Like again, the same example, Randeep X Raj partnership. And then what you do is like go ahead and search for similar documents, and if you find like a good relation, okay, there is actually another contract that is Raj and Sandeep. Let's pull that up and just analyze the first few pages and try to understand between dates. You can use the dates to identify what is the first of all, you already formed the connection. Second of all, you will understand, okay, this date was on the November 30th, now this is on the December 31st. So this is the recent one. And then you can update the document metadata saying this is the recent one. And this can be done only by that initial filtering model you have, the agentic model you have. So that's one way I can think of right now. Yeah, you can have various different ways, to be honest. Oops, I think we rewrote the V2. Oh no, we have it here. We're just updating the agent. Yeah, sure, sure. Yeah, thanks, man. Thanks for that. And also follow me on Twitter. Just search up Ratsudan Gopinath and you might find an account with the same profile image. I don't want to put links over here. But yeah, you can just go ahead and search it up and you can give me a hit on Twitter. In case sometimes I might release, if I release the GitHub or if I release anything, you'll be notified. That's it. Okay, good. You can see all the 18K terms. We never for LOX we never we found anything, but on the new 3.5K filtered terms, we found liquid oxygen, LOX, hydrocarbon engines, thrust chamber pressure, temperature. We basically found um, we have a very good result after this. Like so, this is also one. So this is also uh, yeah, a lot of people, like for example fine tuning, you can have a lot of data, but when you're working in stuff like this, in terms of at least in this like domain specific terminologies, a lot of people think you need to have a lot of information. You need to have 20,000, 30,000, 40,000. Now the thing is, like sometimes even the most simplest approach, the most simplest approach will actually work. And technically speaking, the most simplest approach will only work here because the like you can see the embeddings itself is liquid oxygen. It's not a paragraph, so embeddings will fail. You embeddings will succeed only if it's a paragraph and if it has contextual meaning. For stuff like oxygen, hydrocarbon, rocket engines, embeddings wouldn't have much of a strength. Like it doesn't have a good weight there. So I mean, for like like for stuff like liquid oxygen, like 2 or 3 words, you want to do like augmented search, or second do direct keyword search. That will only match. And I think we're doing keyword search anyway. But overall, the clean 3.5K propulsion text was actually working right for our scenario. So I'm quite happy about it. So we'll move on for the next one. Medical terms, no medical terms, all results are propulsion related and better synonym coverage. And we filtered most of what we want to do. And wanted to verify one more thing. What was that? Yeah, second is augmented. So we'll fix this up and next move on to augmentation. Augmented search, the idea is to let the agent provide more context for better semantic search. Let me update the tool to accept optional context. Okay, yeah. So they should come through the agent. Yeah, so assuming the semantic search works pretty well for this, because you have the thing is still I'm not sure embeddings will have, it might have a decent boost up but not a big, because it's not big paragraphs, right? So but still there should be a good boost, to be honest. So LOX, we're removing all this unwanted stuff and might keep an unfamiliar to me, Java. Okay. The thing is, I want to make the system prompt still much more smaller, because I don't want to give like domain terminologies to be a big thing to focus on this particular thing. We have very important things to like focus on. So I'll just make this concise a bit later. Calling it, okay, instead of calling Claude within tools, we enable augmented search. The tool description instead of this thing example 4. No, I want this to verify this. All right, but I want you to verify this in the first place, because it can, it's Claude in the first. Okay, some. All right, let's continue. And also, I wanted to know what's your choice behind using Python? Wait, what? Is that like, is it? I don't know. Look, like, why choose? The question should be why choose anything else in the first place? Why not Python? I mean, I'm doing. I mean, the things like this for all of this model stuff. You might need to train the model. You might need to like like the Python is the only in all the libraries and everything supports Python. It's a very good question to ask, but there is no reason to use another model for me. Like, so sorry, another language. I don't find anything. There is no need for me to in the first place use anything else. And Python is quite stable, and yeah, I think I've answered your question. It's just a choice, and all of the libraries, packages I use, models, the frameworks, everything is everything gives more priority to Python. That's like the initial. Uh, but also, like in case I want to train the model, right? I want to fine tune models and etc. I wouldn't want to do it in Node.js. I wouldn't want to do it with JavaScript. Like, why in the first place? And also a bit biased as well. I've got started with Python as a language, sort of, I guess, first language, and then I've been just with that, sticking to that. Cool. Still, I don't have a proper answer for you. It's just choice, man. So pass full concepts 18,336. Okay, cool. But I want you to verify this. Okay, not found, excluded. Yeah, that's what. This is a lot of good amount of noise removal here. LOX weak matches. Now you're matching LOX hydrocarbon engines, which is good. Combustion temperature, combustion control, oxidizer, rocket oxidizers, and liquid oxidizers. So when the model was to like if the model is going to perform search, instead of oxidizer, will actually search for rocket oxidizers or liquid oxidizers, and they'll be more helpful in a scenario where you're running an open source model, which has the level of intelligence is much less, and it will need access to domain terminologies and etc. to do that extra level of push in a search. Claude, of course, it knows everything, and you can assume it works very well. And so I can see the time difference, a couple of seconds, at least more than a second. Oops, sorry. Control auto expand. And verification results before 18K. Now you get this combustion parameters. You get combustion. Test 2 propulsion terms working. LOX, liquid oxygen, thrust chambers, oxidizers, hydrazine. Okay, whatever. Specific impulse, turbo machinery, test 3 augmented search models improvement. Uh, test 3 augmented models improvement. Okay. Related reheat combustion context. Mixture propellant context, yeah. Augmentation helped, but isn't dramatic. The main win is filtered collection eliminating, yeah, filtered collection eliminating noise. Yeah, it's just a bump. So just even a little bit push in our case should be more than enough. So I'm gonna go ahead and test the agent one more time to see if it can pull in any. Um, uh, yeah. Okay, give me a query that I can send to the agent. Okay, I don't think this is the right query or something that could, I don't know. Make sure to use the lookup domain terminologies tool and then get back to me with the response. I just want to verify what it does. I think it looks good. I think looks good. So for afterburner reheat combustion fuel, we got afterburners, exhaust system, infrared suppression. So see, that's a good one, I think. And burning process, burning time, and erosive burning. I can see the parallel search being fired, and yes, parallel search has some of the stuff it got from the lookup. Either way, so I think it looks good. It's fine for now. I also want when you yeah. So I want the model to. So the thing is like this. I want the model to be. I don't want. I think it filters noise. So it's automatically doing a lot of filtering in noise. It's not exactly using those terminologies. Only using terminologies which seems to be, which seems quite in the line of the query. So I'm not gonna go ahead and prompt it. I'm gonna keep the prompt as it is. Okay. What else? And it found the right answer, so that's okay. So I think domain terminology is actually solved because we're continuing it from yesterday. All right, so this is good. Now I think we have the initial set of code that is quite stable, that could run on any this thing and etc. Now I want to expose the current documents we have. I think we have about 5,000 documents already. Let me actually connect to let me see, 13 point. Oh no, connect to Qdrant through the IP I have. Host. Anyway, I'm going to first of all connect um to SHS. Let's connect the system. Open the folder. Cool. Now I can just check Qdrant quickly. It's input 633, and let's check for Qdrant. And you can see we have 827,118 chunks. Damn, that's a lot of chunks. And what I can do is that, can I connect to Discord? Yeah, actually I can. So I'll be like, I want you to connect for a different quadrant. I want to pass in the port of it. That's the final collection name. Make sure to update the agent, but keep the other one commented so we can switch back whenever needed. Just keep it as localhost. So it'll make the change and then we can directly start querying it from here. This is when re-rankers would be useful. I think right now I have re-ranker disabled. That's what I think. I want to add it, and then yeah, we'll just start with a very scratch pad. We solved document processing, we'll solve domain terminologies, we've solved tables, formulas, images, whatever, and we've solved infra for 10K docs, we've solved GPU, so we've solved everything. Now at the final part, how are we going to solve an agent that can actually work with limited amount of information? How could it actually work in a given embedding space of 1 million chunks? I think it'll be more than 1 million, I think, by the time we finish it. But yeah, we have to now, this is what we want to do. But yeah, I will take a very simple approach here. Just start off with a very small, start off with what we're building, and we will take it from there. Yeah. And of course, I think we'll work on how to make this sort of fast and etc. But Qudrant, like, we're not going to do anything. We're not going to write any wrappers around Qudrant. Qudrant itself is very fast. I guess the peak was that it can work with 1 million chunks or 1 million something in milliseconds or something. That's if I'm right, that was the benchmark or something. Qudrant. I don't know. I don't necessarily know. Accurate enough. I'm gonna check that out. Okay. Okay. Do not ask me any questions. Oops, there's an error. We have something in port 8000 because we are doing a tunnel, right? So we'll start this port on a different port. We'll do 8. We'll just make something like this. Number like this. API is running to port 5435. Update the agent. No, I mean the front end. The front end should call the backend API, right? And the backend API right now is in port 5435. Because 8000 can't be started because we have docklink servers running on 8000 and we're doing internal. So it'll definitely port forward the request here. So we'll just start it in a different port and we'll try it and see. Okay, try time. Okay. Hello. Okay. Search for LOX. Don't ask me any questions. And see, we didn't still get a response from Qdrant. And I think we won't get a response. No, actually we got a response, but quite slow. I found 20 LOX related results around the archive. We'll thank you. We'll search about this. Find me the full information. So you can read the document information and you can see the metadata that these documents have sections detected. See, just see, I mean, this, I don't know what documents this is in the first place, but you can see we have a lot of sections. We have the document structure. You can see the entire, this is a TOC and this document doesn't have a TOC. We extracted this metadata. This is coming from metadata in 800,000 chunks. Okay, I have no clue. I've never done any custom work for this. You can view the images as well. Oh, right. You can't view images because it's in a different server. Then we need to do like base 64, I think. Okay, but yeah, we'll fix it out. We'll fix that. Good thing we know. Get section. You can see it can read the entire sections. Let's say you have a section, you have subsections. The model can actually pick up that sections because we have document like our metadata is so strong. I'll show you visually show it to with the image. I'll take this PDF, okay, and you see you have something called instrumentation, okay, and you let's say the agent comes across this paragraph and it needs to read the entire section. Usually we have two ways of doing it. One, the agent can move up and down, like how we do it. Then move up and down, get the above or below 300 chunks. If not, if you want to do it in the most if you want to do it in a way that's quite easy, we have another tool called get section, which so this bit basically, I don't want to complicate this paragraph will have a metadata called section heading as instruments, and this paragraph will also have a metadata called instruments in the section heading. So what will happen is that when you come across this particular paragraph and when the model needs to get the entire section of it, it'll just use that particular session ID. For example, here it's using heading as USS Ukraine Zenith. And if I were to scroll down, you get the entire section in order. So if order 83, and then you have this, and you have diagrams here as well. In case the model wants to see the diagrams, it can see it, but it's giving an error because we don't render diagrams. We need to convert it to base 64, but we'll come to that. We know the known issues here. And then you have order 7, same page 15, you have a picture and you have a photograph, good descriptions about that, and you have order 85. So the entire section is properly available, and it makes a lot easier. And this is just, we got this information in 5,000 documents. Don't care about documents, right? It doesn't matter it's 100,000 documents, or it doesn't matter it's 80,000 documents. If your document is actually one page, and if you only have 100,000 documents, it's baby work. It's nothing. Just look at the pages. Here we are working currently. We've already done 129,000 pages or something like that, I think. And don't worry about that. We have chunks worth of 800,000 chunks right now we have. So that's a huge thing to compute. It's a huge work. But among the 8,000 chunks, we were able to find this particular one quite easily. And yeah, we got resources to it. And I would be like, I want to know more information. because I'm not a rocket researcher and I would not know whether it's right or wrong information, but I wouldn't even know whether it's useful in the first place. So this is the tactic I want to play right now. I want to sit down, I want to so I want to basically understand, just go back to Claude and again read the use cases, the simulation, and see how could we, how could we build that first initial, how could we make something that's like sort of, I guess yesterday I did explain it in a radius sort of sense. So I guess if you withdraw thing, so I will explain it to you one more time. What we are essentially trying to do is that, yeah, I will get this particular example, right? Assume this is actually the entire image is actually, open the image. Yeah, assume this entire image is 800,000 chunks, right? Now, what you want to do here, okay, wow, not wow. The parallel search was also done, and I think it took a bit of time because, of course, there's a lot of stuff. I want to make it fast. Let's focus on all the fast stuff later. Yeah, the one stupid thing that it did was that Dockling did give me a lot of um a lot, like I didn't use 5 to, I didn't have a minimum, I didn't have a minimum amount, a good minimum for chunking. So I didn't chunk it on 256. I chunked it based on paragraphs. So some paragraphs might be big, some paragraphs might be more than 256. That's how I did it. But yeah, it's still useful. You can still expand the k top to be 20 or 30 or something like that. So it's fine, it's fine. And it found the right document, so as long as it finds it's okay. Cool. And you can see over here, just assume this is the 800,000 chunk space, and you have a question, right? Initially what you have to do is that and let's assume documents are scattered across pages. What you have to find is that you need to find that one small spot of good information. Now, of course, in embeddings, it's not like location. It's not like, it's near, it's like you don't have any correlation in terms of location. It's scattered through. You don't have it. It's not a map. It's not a map like this. But what I'm trying to say is that we have to boil down to a very small embedding space and then expand from there. So so the X can come here, right? It can come to Pittsfield. The X can be in Vermont. The X can be in Montreal. It could be anywhere. But how do you decide this is where I need to start and this is where I need to expand? That's the initial shot. Like you have 800,000 documents. That's the most important shot for the agent, where it's the starting point for the agent. You're giving something and it needs to identify something in 800,000 chunks. Where should it start? Like that location, you can assume it to be like a map. That location is very important. That location decides whether the agent will come across proper information or not. So then what we do is that we do a lot of, I think I have a little bit of things in mind, which is like filtering documents, filtering based on keywords, or just trying to do like a hit. So for example, right now the first parallel 5 searches that did run, right? If I go over here, you can see we have a parallel search going on, and these were the queries, and we got we basically got all of these results. And this parallel search is actually like a hit catch, where in a black box, in a black box filled with so many, I don't know, in a black box filled with valuable information. What is that right location in a very big black box? Where do you start? That's where this helps. You just hit like parallel searches, keyword or whatever, with some keywords to get a hit, to get a feel on where it could, what is that you're working with. And once you boil down to a location, then you go ahead and expand, look into documents from there, look into references inside documents, look into metadata inside documents and stuff like that, and then you take it from there. That's the overall goal. Now, because the document, the model already has access to notes and all of this stuff, it can reason through stuff properly and find it. Now, I'm only worried about this. The stupid thing that I did with chunking. So I didn't chunk it properly. I won't say I didn't chunk it properly, but for example, in parallel search, you can see the number of results we get. These are what is this? These are text, like basic text. You can see the text is nothing. This is the entire text. It's not a paragraph. If the chunking would have been better, we would have got a better result, but it's still okay. What I want to do is that what I can do is that if there was a way to skip the minimum amount of text is available in a chunk, then I would do that. So what I would do is that find paragraph that's actually more than 256 chunks or something like that. So I'll be like find paragraphs that are more than 256 chunks. Okay, something like that. Find paragraphs that are more than 256 chunks. And you can do it based on filtering. Of course, Qdrant can do it, and this is only for parallel search. So then parallel search, I don't want it to be come across. That's like a workaround that we can have with this thing. And yeah, it's an example that I want to give. Cool. We'll continue. So the thing is, we'll get started in the brainstorming. Okay, so I think I actually had one conversation going with Claude. Search for Sandra. Yes, this is the one. Okay, Sandra, cool. I want to move this to add this to a project, put it to YouTube series. And rename this. Okay. And then what I want to do is that copy this. This is what we are building, and just take actually project info. Copy this. And yeah, just send this in the first place. So it will analyze the conversation, do some random work, which I have no way of conveying into, and it will do some random work and then come back to me. Why is it fetching from motion? Yeah. All right. So we have a very good standard. So I'd be like, so this is the current status. We've solved document processing, and we have about 800 and 800 and 870,000 chunk till now, and we only 50% done. There's another 50% documents to be processed. Now, I would like to have a fresh mind, and you know the goal, what we're trying to do, you know how we're trying to influence the model and etc., and try to build this agent. But I want to know, and we have about, and at the end we'll have about 10,000 documents, and each of the 10,000 documents has an average page size of 67 per page. So you can assume how many pages of content we'll have saved in our database. So overall, I'm trying to, you have a fresh mind and understand, the agent. So when a user gives a query, right, the agent would need to only look at 40 to 50 documents at a given moment to come up with the right answer. That's the truth. But how do we go about searching? How do we go about finding that right thing or the right few documents in that 10,000 document space? And I also want to understand how, for example, in terms of like a location, how do you structure the radius? How do you start with in a right position and then you expand towards it? And how do you do that? Because because what I'm trying to say is that I want to mimic how engineers do this work. Not complicate this at all in the first place, because agent's context is also limited. So that's why. So I'm thinking that in a given day, an engineer, I'm pretty sure that the engineer is not going to read all 5,000 6,000 files. He's not going to do it. He's basically gonna do like read a few things, do some sort of work, and try to boil down to that few docs or few important docs. Like, even though they have, I'm sure the companies have 100,000 documents and the users are able to find it properly. It's just they're slow and they're inefficient. They could have been, the job can be very much better with a lot of explanation using LLMs. But I'm trying to understand a user's perspective. At the end of the day, they're not reading 100,000 documents and coming up, trying to come up with a solution. They're literally only reading if maximum 30 or 40 documents. So I want the LLM to do the same thing as well. So I want to take inspiration. So that's what I just want to leave the ground and just try to understand the reality of it. If the human can find, if a general researcher can find the right document or the few documents, in the same 100,000 space, the agent can do it as well, and it can mimic and how a research agent could do, a person would do, and even 10x better with all the embeddings and etc. But I'm just curious to know about like how they go about it, so I can try to understand their the traditional way of solving this, which is already solved. But and then we can go from there, I think. But before you give, yeah. So anyway, I was just blabbering some unwanted things as well, because I wanted to get everything right, but I'm just gonna send it anyway. Claude will get it. Claude will get it. So let's go through this. Yeah, this makes sense, but but you know, like the LLMs are of course LLMs have an issue in context, but with embeddings and with search and etc., I think we have to get inspiration from users, you know, day to day, whatever, you know, how they approach this, but also approach it in a way that the uh, with the current capabilities of LLMs and embeddings and all of this stuff and all of the entire stuff, we have to approach it in a way that that doesn't, I mean, take inspiration from the from the actual user, or maybe the actual researcher, but also, you know, try to do it in the most efficient LLM native way, or maybe you can call it the most efficient, you know, LLM native way, to be honest, because LLMs can do so much. You can search through, you can do parallel searches, you can do a ton of things. I'm not talking about the tools and how to use tools. That's not what I'm talking about. I just wanted to know, you know, if LLMs are much more powerful. You have embeddings and etc. A human can never search to do perform a semantic search till now. So just curious to know what are your thoughts. How would an LLM native way, given the capabilities of a system, how would this look like in a LLM native way? Just curious to know. So just trying to be random here, just trying to see, you know, if this is what human do. We don't want to exactly clone the human. That's not the whole point. Then it'll end of the day become like a human on top of semantic search sort of a thing. You know, LLMs, I know, even with a lot of course context issues, the LLMs can navigate at you know, at like, I don't know, it at tremendous amount of speed and with good amount of context as well. So I want to know that there's just random conversations. I don't have any aim here. I'm not here to, you know, find, okay, this is the way, now we're going to do it. That's not the way at all. Just random conversation that hopefully will open up some, you know, some insight, some new information or whatever. So just random stuff. Find paragraph more than searching. Okay. You're right. Let me actually think about this differently. The human limitation that, I mean, of course, I didn't want to go through this stuff again. I think this would have made, I mean, this would probably make sense for you. This should make sense for you. I don't want to, yeah, go ahead and, you know, again talk about this, but yeah, essentially the radius factor that I talked about. Human navigate because they can see the space. They walk into darkest forest with flashlight, finding one tree around on items with embeddings. They have a map of entire forest from above. Yeah, yeah, that's a perspective shift UAV and also speed shift. Like if you were to look at like an LLM native way of doing it, you can see where all the trees are, where the trees are clustered together, which areas are dense, which are sparse. Why would we make an LLM walk this with the same flashlight? Exactly, the LLM native insight. And it's just fun to read stuff like this. Because you can't search. Hmm, this is a good point. find me chunks that are similar to this chunk but different from documents. Yeah, exactly. I mean, like it's not gonna exactly perform this, like it's not gonna go ahead and search for this, but you get the point. It can filter, find the same things across other documents. The thing is, we should have we could fine tune the embeddings, guys. Like I want to do it in the next maybe next project or whatever. I plan for that. Then there's fine tuning embedding models itself is like that's where instead of fine tuning, you can have like the augmented search, whatever the current stuff we have, and then improve the embedding models. Just this is invisible. Yeah, so this is also a good point. We don't want to have all the chunks and everything inside the memory of the agent. Good. This is very good information. So I want to spend more time in this as well, but overall you get the point. This we just have to make changes to the agent a little bit, and then we should be able to test it out. But before even this, we need to have strong evaluation framework. Like for example, like I want to know whether that particular fix was right or wrong, right? Like I want to know whether that question was right or wrong in the first place. So what I would do is that I would get 30 documents, and copy all the chunks, put it to Gemini. It can handle 1 million tokens, and then because it can because memory. So Gemini's reality is that it can load the entire 30 documents and create a complex query that involves checking all 30 documents. But here in our agent is actually not is actually searching among 5,000 documents. You understand? So even though so this could be a very good evaluation framework because Gemini has access to the entire document history and then generates a question, and Gemini can do it, and Gemini knows the answer for it as well. But our agent is actually completely starting in a very blank space, and the agent would actually need to scope through the 5,000, check all the 5,000, and then try to find that 30 in 5,000. So that's how I think we should go about evaluation. So we need to set this up and then start searching this. Okay, guys. So I'm gonna quickly go and take some lunch and come back and select the beautiful image for lunch. And okay, all right, guys. See you in a bit. இது சாப்பிட்டீங்களா? All right. So yeah, what I'm going to do right now is to put this as a text, so Claude could start analyzing this a bit. We're just having conversations. We don't have nothing yet planned or whatsoever. We're just simply having conversations, trying to gather information, gather points, gather relevancies, gather intricate parts of information that could be useful for building the agent. I will like conversation.md. All right. Now we are going to be working. Now we are going to be working on something very important. All right, now we're now going to be working on something very important, basically. This document is about 65 pages on average. This thinking. Yeah. A lot of thinking and checking. A lot of thinking. This means we need to have a lot of thinking. Okay, now I'm gonna go ahead and create. I'm gonna go to AI Studio. So the thing is, most of this stuff is already there. And I want to quickly check if we've already solved how it works as a base, like basically, at least with whatever we have right now, how does it work? And how does it work for, let's say, once we do the changes, we need to be able to measure all of those, right? The current system is well designed for native approach. The potential gaps are landscape analysis. Yeah, so we've already solved most of them in our past agent designing video. Landscape and agencies are relevant, but not distribution chunks. Semantic neighbors, no tool to find chunks similar to this, but from other documents. Document level can't quickly see if 50 documents are relevant before having it to. Yes, this is very abstract and whatever the information. The thing is, like, this metadata might not be there for all the documents, so you can't do it. And I also want to add a few more information. For example, I had one info here which was related to LLM curating when it enters here, curating what it needs to enter before its context menu. This is the last part. We'll come back to this once we solve everything. Multi-resolution search, we need to have strong list. Yeah, this is where we'll do parallel agents. Parallel agents would help. Find paragraphs more than, yeah. So this we have to do. Mitigation, institutional scopers, okay, all of this stuff. Cool. I think what I want to do first, create another Claude instance. Mm. What one do we have? So, the phone. Documents. but our system needs to. Okay, but so what I want to do is that in Qdrant you might have a lot of documents. I just want to, do some sort of search or some sort of filtering and then find about in some way, not accurately, but just try to find about find a document that is quite, what do you call it, quite relevant. And then what we want to do from there is that create a data set, connect the Qdrant, get that, and load the entire 20 30 documents to entire 30 20 to 30 documents to Gemini. Or again, this supports about 1 million tokens, I think. So we are good here. And then create question answer pairs, which then I can send it to Quadrant and yeah, get it sorted out. Yeah, sorry, send it to I'm sorry, I'm blubbering. Send it to our agent and then try to the thesis is this: you have 5,000 documents or 10,000 documents or 100,000 documents, doesn't matter. For a certain query, the agent would only need to look at 30 or 40 documents. At the end of the day, that's what the agent can do. It can only look at 30 or 40 documents at max. It can't look at 10,000 documents and come back. You understand, right? We're not really doing any pattern matching system or something like that. So, because it has a limitation on context, usually, and of course, it can solve your query as well. And yeah, so the point is very simple. Doesn't matter the amount of documents. Of course, it matters in a scale, it matters for accuracy, but for the agent, it only needs 30 documents. So it needs to find that 30 documents among the 10,000 documents. That's the hard part. But if you find 30 documents, you find the right 30 to 40 documents, you're done. The job is easy. So that's what we're trying to do. Trying to, create a data set of 20 to 30, load everything up to Gemini, and then answer, create evaluation sort of test. Now, Gemini could accurately give me an answer because it can load the entire 30 and then have relationships and etc. And then, simulate some sort of cross-checking sort of work. And then when I ask our agent has need to figure out those 30 in a space of 5,000 to 10,000. Then we'll know how it's currently performing and then we can move forward with the next one. So connects to quadrants, get the collection, extract all the unique ideas, samples, document, understand topics and themes, selects a thematically coherent substantive evaluation. Okay. Yeah, just it doesn't need to be accurate, it's just somewhat relevant enough, that's more than enough. In fact, we can randomly get documents, not an issue at all. But yeah, I just wanted to slightly do it in a slightly better approach. Actually, what I'll do, I will run it. So I get a chance to see all the logs and extra. I will do just put Claude here because this space is anyway not used. So doing it for all the points will take some time. So that doing it for all the points might take some time. Actually, maybe it's doing for only 200 points. 200,000 points. No, it's actually doing for everything. So maybe shall we just do it for the 100,000 or 200,000 points? 100,000 or 200,000 points? Because you can see not a big difference. 6,747, 6,754. Not a big bump, only a little bit, slight bumps. And I think the others are chunks, so you only have around 260,000 of, no, others are chunks, yeah. Just asking, is there any red flags or any issues with this? Of course, it'll give a lot of red flags, but we'll just decide. No red flags, okay? Yeah. So this should be done now. Okay, got the first 50. I think it's gonna be huge for sure. Okay, so I guess a very decent analysis. The first, of course, not the entire points, but we'll have a decent testing point here. Just okay. Select Yeah, we'll create 25. No, actually, I want a folder that has 25 documents, and each of the documents should be an entire document in order. So that's what we want. So then I'm probably using that for evaluation. I want to send this to another yeah, something. Yeah. You might not need to know about it, but you essentially want to save each and every document in order. I mean, in order meaning like inside a document should be in order, right? Because Qdrant chunks could be everywhere. A document should be in order, and I need 25 documents saved in a folder. That's what I want. Yeah. Also note I need the MD file because I have a PDF to I have an MD to PDF converter which I can run in the terminal, and you should convert all of them to PDF if needed. If needed, I don't think needed, but just for the sake of it. You guys, I think I might have to end the stream. Sanjay, alright guys, so I think I need to wrap up the stream. Um, so this is exporting. I think the stuff is going on for exporting. So this will take time because we have about how many chunks? Save 436, 400. There's a lot. So there's a lot of chunks saved. Okay, I think we're done. So we'll check it out. Eval documents. First one in MD. Yeah, we did a lot of noise removal and etc. But of course, you can still have issues. So the thing is, you could see because of the chunking that I forgot, I literally forgot to put a minimum of 256. That's why you can see each chunk, like this is a chunk. Like you don't need this to be a chunk, right? This is actually a chunk. So I'm just trying to see if once all the documents are done, I'm just trying to see if I can group them. Understand? Just remove the, but again, the order might be affected, so I don't want to touch that. Anyway, it's fine, not a big deal. We just remove, like even small chunks are not much needed, right? You can merge them if that's needed, or what we'll do is that we will I know we'll find a way, not an issue. So these are okay. You can see the 69 page 35. So this is a huge document. How many pages that? This is 145 page, this one. And this is also so these documents are quite big, and that's why you see like we actually planned to have, like, for the entire 10,000 itself, like less than a million chunks, but already by 55,000 documents we're at 800. So that's the reason. This is the reason you will have less depending on how, like, what's the minimum amount of this thing you use to chunk it. Cool, don't make the mistake I made, but anyway, um it's too late for me to rerun the this thing because it's uh, already it's, already 50% of the documents have been processed. So that's about the 40 hours of compute time. I don't want to run it again. So I'll find a way around, and also you should also find a way around. Sometimes you're working with documents that are very small in chunks. So if you let's say you come across with an issue like this in the middle, right? How do you solve it? I don't know yet, but we will see. So that's one thing to do. Apart from that, documents looks good. I don't think I'll just send everything to Gemini because the total chunk. Oh, no, total chunks are 1,250, but like one chunk might have I don't know, 300, So the entire chunk of all the documents might be around 200,000 tokens. I can still send it to Gemini, but it might struggle a bit. So anyway, I'll just upload all the 200,000 chunks and see it for yourself. Okay, so yeah, we'll come back and see what we can do with all of this stuff. Next is, of course, evaluation, testing the current agent, seeing where it fails, where the gaps are. I think there'll definitely be a lot of gaps. I think, yeah, a ton of issues might come up, and okay, it's here. I thought this was deleted. Shit. I'm gonna take a snapshot of this and just keep it somewhere in case. You would never know, in case something goes wrong. Okay, either way, guys, look around. I've created a snapshot. Probably it'll take some time. I'm not sure. But apart from that, okay, now we thank God we have 4.4 GB. In case this fails, right, we can just pull it from this. Uh, yeah, it won't. It shouldn't fail. Then again, I have to do the entire processing just for one extra amount of safety. Simple. Alright, guys. Thank you so much for watching the stream. If you have any question, feel free to DM on Twitter or whatever, maybe on the next stream or whatever. Happy to answer them. I answered a few questions today, so yeah, leave it there. Thank you so much for watching, and I'll talk to you guys soon. So the next, yeah, again, next is evaluation, identifying gaps, and yeah, system is done. Okay, but that's the most complex part here, so we'll figure it out. Thank you so much, guys. Talk soon. Bye.